Hello everyone, welcome to the revision series of chemistry by ANR. This is the revision of chemical kinetics chapter. So we see the integrated rate equations first. For zero order reaction, the expression is T is equal to R0 minus R by K. Zero order reaction means reactant to product. Rate of the reaction is equal to K into molar concentration of R raised to the power 0, which is equal to K. So it's constant. Now T half is equal to R naught by 2K. For first order reaction, T is equal to 2.303 by K log of R naught by R, where R naught is the initial concentration of the reactant and R is the final concentration at time T. T half is equal to 0.693 by K. For this particular unit, remember the values of log 2, log 3, log 5 and log 7. You have to remember the values of these. Now, let me tell you that CBSE is providing log table, so you may get it or you may not. But these are the values, if you remember, will help you. Now, T half for the first order reaction is independent of the reactant concentration. Nowhere you can see that reactant concentration is involved, whereas it is involved in a zero order reaction. It is R naught by 2K. That means I can say T half is proportional to R naught for a zero order reaction. Now, amount of substance left after n half lives for a first order reaction is R naught by 2 to the power of n. Remember that all the radioactive disintegration, they follow first order kinetics. Next, Arrhenius equation is K is equal to A into e to the power of minus EA by RT, where K is the rate constant, A is Arrhenius factor or frequency factor. It is also known as pre-exponential factor. E to the power of minus EA by RT is a fraction of particles having energy either equal to activation energy or greater than activation energy. So it is either having energy equal to activation energy or greater than that of activation energy, which is EA. Now for this we can say log of K2 by K1 is equal to EA by 2.303 R T2 minus T1 by T1 T2. That is rate constant at T1 temperature is K, at T2 temperature is K2. So K1 is the rate constant at T1 temperature and K2 is the rate constant at T2 temperature. Now let me tell you one more thing. That if R is having the value of 8.314, then remember one thing in your calculations, will you always calculate 2.303 into R where it is 8.314 if it is. So for this, remember one thing, this is equal to 2.303 into 8.314, which you are not going to calculate again and again. Remember it to be 19.14. This, if you remember, then your calculation becomes easy, and many a times you will get to see this, that 2.303 into 8.314 is required. So the value you remember 19.14. That will make your calculation easy. Okay, next moving on. In a plot of log K versus 1 by T, you will get this relation. For a first order reaction. Now, characteristics of catalysis reaction or catalyst. They does not alter the delta G of a reaction, that is a change in the Gibbs free energy is not altered. They does not change the equilibrium constant but helps to attain the equilibrium faster. Catalyst actually catalyzes all spontaneous reaction but does not catalyze non-spontaneous reaction. Next, graphical method of order of a reaction. That means nature of the plot you see and you detect what is the order of the reaction. Over here you can see this is one where rate against concentration you are plotting, and if it goes parallel to the concentration axis it is a zero order reaction, and if it goes straight linear plot from the origin passing, so it's a first order reaction. For the first order reaction, see, if the first order reaction, all radioactive disintegration is of first order, and over here I have shown you that from a reactant to product, this is how in a differential form rate expression you write it. Minus ddt of R is equal to K into molar concentration R raised to the power 1, because it's a first order reaction. Negative sign is showing that with respect to time the concentration of the reactant is decreasing. Now these are the two plots, log R versus T, having a slope of minus K by 2.303, and log R naught by R versus T having a slope of K by 2.303. Zero order reaction. Zero order reactions are enzyme catalysis reactions are examples of zero order. All surface reactions, adsorption process, occlusion process, they are all surface reactions and they are of zero order. Now this is a plot, concentration against time having a slope of minus K, and you can see T half against R naught having a slope of 1 by 2K. These are the plots. Now here again I have shown you the differential form. Minus dr dt is equal to K into R to the power of 0, which is equal to R to the power of 0 is 1, so is equal to K. So these are the plots for the first order reaction. You can take screenshot if you want to see it. It is just a revision. You will get everything in NCERT and see this. This is the plot for the zero order reaction. Now, units of rate constant for nth order. If you study for a general reaction, then you can place it in any order of the reaction. So if you assume reactant to product, this is the elementary step. Rate of the reaction, that reminds me, elementary step means a single step reaction. So elementary step, that means a single step. Rate of the reaction is equal to K into R, molar concentration R raised to the power N, because I am assuming it is nth order reaction. So K is equal to rate by R to the power of N. Rate means concentration against time, change in concentration with respect to time. So I have written concentration by time into molar concentration of reactant. So concentration raised to the power N. Now concentration term means mole per liter, molar concentration. So unit of K is concentration to the power 1 minus N, mole per liter to the power 1 minus N, time inverse, so second inverse. So this is the unit of K. You can place the value of N and you can get the unit of K for zero order, first order, so on. In your syllabus you have zero and first only. And this is the general expression for A moles of A, B moles of B forming C moles of C, D moles of D. A, B, C, D, that is the lower case, they are the stoichiometric coefficient, and R average, that is the average rate with respect to a duration of time, T2 minus T1 or delta T, is this. That is, always remember that in the rate expression with respect to the reactant there is a negative sign, with respect to the product there is a positive sign, and you need to divide the expression by the stoichiometric coefficients. Now instantaneous rate means delta T tends to 0. There is no time difference. At a particular instant you are finding the rate of the reaction and you reduce it to ddt. So ddt of A, again you divide by the stoichiometric coefficient. So the rate expression is like this. Unit of rate means change in concentration with respect to time, so mole per liter per second. For gaseous reactions, atmosphere per second. Now again, negative sign in the rate expression, what does it show? That decrease in the concentration of reactant, and gives the negative sign is given in order to give a positive value to the rate expression. Now this is a gas phase reaction. You can see reactant products, they are all in gas phase. If Pi is the initial pressure of A and Pt is the total pressure at time t, and Pa, Pb, Pc are the partial pressures of components, or rather I'll say of the reactant A, products B and C, then the total pressure is a summation of the partial pressures of all the gases. Now for this, K is equal to 2.303 by T log of Pi by Pa. Or you can say that K is equal to 2.303 by T log of Pi by twice Pi minus Pt. Numericals are there using these formulas. Next we see pseudo first order reaction. Pseudo means false. So it is not a first order but becomes a first order reaction under certain condition. Example is inversion of cane sugar, which is a bimolecular reaction. That is, in the rate determining step, two molecules are getting involved but is a first order. Why? Because we can see over here C12H22O11 plus H2O. It is acid catalyzed and we are getting 1 mole of glucose and 1 mole of fructose. Rate of the reaction is dependent on the molar concentration of C12H22O11 but is independent of the concentration H2O, because with respect to time the concentration of H2O doesn't change because its quantity is so large. That is the reason why it becomes a pseudo first order reaction. Do not forget to revise the difference between order and molecularity in this chapter as well. I hope the revision video was useful. So see you in the next video.